Hey, Jonathan here at Colfax Math. Today I'm going to go over IB Math SL from our Oxford textbook. I'm in Chapter 12, Periodic Functions, and we're going to start at 12G, looking at graphing both sine, cosine, and tangent. So let's put the camera over my shoulder and get started.
Measure the height. Yeah, no, measure the width from here to here.
Laminated over. This is a quick overview or review. Sine, if I use my mnemonic device, so katoa, sine is the ratio of the opposite over the hypotenuse. So it's this leg over the hypotenuse, and I could start drawing all these different triangles, and I could see that opposite gets larger and larger and larger until the opposite and the hypotenuse are the same. So at 90 degrees, my ratio of sides is 1. But then after that, as I rotate around over here, my opposite is getting shorter and shorter and shorter until I'm back down at 0 on the y-axis at 180 degrees. And then down here, I can see my opposite is negative because it's going down, and it's getting longer and longer in relation to the hypotenuse until right here at 270 degrees. The corresponding y value, the ratio of sides, is -1. And then over here in the fourth quadrant, I keep rotating around and I graph all possible triangles, and I see it gets closer and closer to 0. So that gives me my basic sine graph. It starts at 0 on x and on y, so it goes through the origin. And then on the x-axis, as I get closer and closer to 90, it approaches 1. As I get to 90 and go past it, it goes back to 0 on y. Then in the third quadrant here, the relationship is negative because it's the opposite is down, and it's getting closer and closer to -1. And then right here at 270, it hits -1 exactly. And then as I go past that, it starts to go back to 0. So the ratio of the opposite to the hypotenuse is 0. So you could do this in degrees, 90, 180, 270, 360, or the radian equivalent, 2 pi, pi, half a pi, so 1/2, 1, 1.5. So a quick overview of a sine. The important thing to remember is it starts at the origin and it goes up. The first quarter is 1, the second quarter back to 0, the third quarter -1, and the fourth quarter back to 0. So that's your sine graph. If I did that exact same thing as this, but instead of looking at the ratio of the opposite to the hypotenuse, I looked at the ratio of the adjacent to the hypotenuse. As I look at the adjacent to the hypotenuse, and I do the same triangles, I could see my adjacent here for cosine. So this is y equals sine, y equals cosine. I can see my adjacent is 1 and my hypotenuse is 1. So cosine actually starts up at 1. And then as I rotate here, the adjacent gets shorter and shorter. Right, here's the adjacent here, getting shorter and shorter. So at the first quarter, it goes to 0, so at 90 degrees. And then here, the adjacent's starting to get longer and longer in a negative direction, and it's approaching -1. And right at 180 degrees, the ratio of the adjacent to hypotenuse is -1. Then down here in the third quadrant, that adjacent's getting shorter and shorter and shorter and shorter. So that's why it goes back up to 0 at the third quarter, 270 degrees. The adjacent right here in the fourth quadrant is really 0 at 270, and then it starts to get longer and longer and longer until the adjacent and the hypotenuse are the same, and at 360 degrees it's back to 1. So y equals sine of x. This models so many things, from engine motion to lunar cycles to planetary cycles. Sine of x goes up to 1, back to 0, to -1, back to 0, just like electrical current. So that's your sine graph cycling in 2 pi or 360 degrees. Y equals cosine of x, starts up, drops to 0 at the first quarter, down to -1 at the second quarter, back to 0 at the third quarter, back to 1 at the fourth quarter at 2 pi. Then what we're going to do with those is we're going to change the amplitude, which is the overall height, the period, which is how quickly it cycles, the vertical shift, and then the horizontal shift is pushing it over. Okay, so let's just take a quick look at some of these right here. So the first one is y equals 2 sine of x. Y equals 2 sine of x. You could just graph that as a regular sine graph first, and then put your numbers in afterwards. This 2 changes the amplitude from 1, up to 2. So it goes up to 2, down to negative 2. The period is still the same, 2 pi. Number C here, y equals 2 cosine of 2x. This value right here isn't your period, but it gives you your period. If you use 2 pi divided by the value in front of x, that gives you the period. So it's equal to pi. This right here is your amplitude. So this is a cosine graph, so it starts up, ends up. It is not cycling in 2 pi anymore because of this 2. It is cycling 2 pi divided by 2, or pi. This 2 right here is the amplitude. So the high point's 2, the low point's negative 2. So those are, I'll just do one more. Y is equal to negative 1/2. That's the sine of x over 3. Well, x over 3 is really the same thing as sine 1/3 x. So the amplitude is always a positive number. So the amplitude in this graph, the amplitude is 1/3, or 1/2, sorry, 1/2. It's the absolute value of that. That negative is going to reverse direction on the sine graph. So it's going to go like that. So the negative reverses the direction, but the amplitude is still a positive. So let me draw that sine graph, starting at 0, ending at 0, talking on the y-axis here. First quarter down, third quarter up. It is going to go up 1/2 and down a negative 1/2, and that negative is reversing the direction of it. The next thing I need to do is look at this 1/3. So I'm going to do 2 pi divided by 1/3, which is 2 pi we'll do it again, divided by 1/3, which is equal to 2 pi times 3 over 1. The way you divide fractions is multiply by the reciprocal, so that gives you 6 pi. So a total of 6 pi. The whole cycle is 6 pi. Half cycle and 3 pi. This would be 1.5 pi and 4.5 pi. Turning the page here. Given the picture, what is the graph? Well, I can see this is a sine graph right here. So 3a is y equals sine of x. And then I need to look, the amplitude would be 1. So there'd just be a 1 in front here. And the period, it cycles in pi. I don't know if you can see that. It cycles in pi, or 2 cycles in 2 pi. So that means if I put a 2 here, it's saying it's doing 2 cycles in 2 pi, or 2 pi divided by this 2 gives me pi, how long it takes to do a cycle. Let's look at a few more of these right here. So match the function with the correct graph. A is y equals 3 sine of 2x. 3 is an amplitude. 2 pi divided by 2 would be a period of pi. So I'm looking for a sine graph with an amplitude of 3 and a period of pi. So I could see that one's pi right there. B, I'm looking for a negative cosine graph. So that's negative 2 cosine plus 1. This is a horizontal shift to negative 1 that way. So I'm looking for an upside down cosine graph with an amplitude of 2 that goes that way, negative 1. So down here is a negative cosine graph. with an amplitude of 2 to negative 2, and it's a negative cosine graph, so upside down cosine graph, starting right here. And I know this is negative pi, 3.14, 1.57, so 1. So B would be option 2 right here. I'm looking for a sine graph here with an amplitude of 0.5, 0.5, and a phase shift or horizontal shift of pi over 2 to the left. So this is a sine graph starting here, ending there, with an amplitude of 0.5, and that phase shift of negative pi over 2 puts it over there. I'll let you do that. Last one, over here, find the equation of the function. So let's see right here, I'll just jump down to C here, find the equation of that function. That's going to be a cosine graph. That cosine graph is shifted down negative 2. So it's going to be y equals negative 2 plus the amplitude of that cosine goes from negative 2 to 0. So it goes 2 and down 2. So plus 2 cosine of x. And then the period, it cycles in 2 pi. So the period's 2 pi, so there's no change in that x value. So there's a vertical shift. It's a negative because the thing's pushed down there. Looking at a couple more here. I'll jump over to number 6, solve for sine of x equals 1/2. With that, you take the arc sine of both sides, and you know the arc sine of 1/2 is going to be a first and a second quadrant value, where the opposite is 1, the hypotenuse is 2, or over here, opposite is still positive 1 over 2. So you recognize that as a 30 reference angle, or in radians it would be pi over 6 and 5 pi over 6. The domain is 0 to 4 pi. So I would also do another full revolution to get pi over 6 plus 2 pi and 5 pi over 6 plus 2 pi. So those would be my other two values. So would that be 12 pi over 6 plus 1 would be 13 pi over 6, and then 17 pi over 6. So those are my solutions algebraically. And then graphically, you could see it would be the same series of solutions. If I graph the sine graph, there's 0 to 2 pi, but I'll graph it from 0 to 4 pi. I graph a sine graph in 2 cycles over 4 pi, and I'm saying the y value is 1/2 right here. What are the corresponding values? Well, this right here would be that pi over 6, 5 pi over 6. This value right here would be 2 pi beyond pi over 6. And this value right here would be that 2 pi beyond 5 pi over 6, or 17 pi over 6. This one about natural growth, number 7. If you skip that, that's fine. We really haven't talked about E. Number 8 says graph a sine graph and a cosine graph on top of each other. So here's my sine graph cycling in 2 pi. Then my cosine graph, do it in pencil here. My cosine graph would start here, low point right there, and cross right there. So in pencil here is y equals cosine of x, and in pen is y equals sine of x. We'll show that a cosine graph is just the phase shift of a sine graph. Well, I could see that this cosine graph is really the same thing as the sine graph pushed over 90 degrees. So a sine graph and a cosine graph are really the same thing. A cosine is a sine pushed over pi over 2. Copy and complete the sentence. Graph y equals cosine of x may be translated to a horizontal push of pi over 2 of a sine graph. So hopefully that helps you get started on these graphing. Tangents next, and that kind of wraps up chapter 12 in IB Math SL in the Oxford textbook. Thanks for watching. Hit like and subscribe if you like the video and you want to see more of these.